let's verify the abelian group properties of the set of continuous functions on the interval a to b inclusive under addition of functions. First, closure. A theorem of calculus provides this. It goes as follows. If functions f and g are continuous on the interval a to b inclusive, then their sum is also continuous on that same interval. Next, the associative property says that if we pick three distinct functions, f, g, h, that are continuous on the interval a to b inclusive, then if we add f plus g to h, our result should be add f to the sum of g plus h. So we want to verify this. So we need to remember, we need to remind ourselves what is the meaning of function addition. Well, if we have that f is the set of ordered pairs xy such that y is formulated by f of x and g is the set of ordered pairs xy such that y equals a g of x, then our definition of addition, function addition, says that f plus g is the set of ordered pairs x comma y such that y equals f of x plus g of x. Now, the way to abbreviate this is f plus g evaluated at x equals f of x plus g of x. So let's work with that. So to express this in an abbreviated manner, we will say that f plus g, the function f plus g, is defined by f plus g evaluated at x equals f of x plus g of x. So we're going to work with that. So let's proceed to write out the meaning of this left-hand side. What is f plus g added to h? Well, it means f plus g added to h evaluated at x equals to f plus g evaluated at x plus h of x. But now, what is f plus g evaluated at x? It is f of x plus g of x. Now, that is a single entity, so we're going to parenthesize that result. So we get f of x plus g of x plus hx. Now, what are we looking at in here? A real number, a real number, a real number, and this is an addition of real numbers. Now we know that the set of real numbers together with addition of real numbers is associative. So we're using now the associative property of real numbers under addition. So that gives us the right to transfer the parentheses now. So we obtain f of x plus the quantity of g of x plus h of x. What justifies this? The fact that this is addition of real numbers. So we could say because the structure of real numbers together with addition is associative. Now, let's now begin to rewrite this back into what it means. So, what does this mean? This means f of x plus, what's inside the parenthesis is g plus h evaluated at x. But finally, we're going to use that same rule again here. Here is my function f, here is my other function g plus h. When you add them, when you have f of x plus g plus h of x, that is the same as f plus g plus h evaluated at x. And our goal has been reached. We started with the meaning of the left-hand side, and we ended up with the meaning of the right-hand side. Let's now verify the commutative property. Verify that the function f plus g equals the function g plus f. So, what is the function f plus g? It's the set of ordered pairs x, y such that y equals f of x plus g of x. So write this in an abbreviated manner, f plus g of x. What is that equal to? That equals to f of x plus g of x. This is additional real numbers, so we can commute because addition of real numbers is commutative. So this is equal to g of x plus f of x, which means the function g plus f evaluated at x. Next item. Let's verify that our collection of continuous functions on the interval from a to b inclusive contains the identity element, an identity element, which is the identity element, which is the zero function. The zero function acts as an identity, and it belongs to the set of continuous functions on the interval a to b inclusive. So our function exists. This is the zero function. So let's define, let theta of x equal to 0, that's the zero function, for all x in the interval from a to b inclusive. We want to perform two calculations. Give me a function in the set of continuous functions in the interval a to b inclusive, added to our function theta, and confirm that it is theta does act as an identity. So let f be a continuous function on the interval a to b inclusive. So two calculations we need. We need to find what f plus g is, and f plus theta. This is our subject identity function, and we also need to find out what theta plus f equals. Our contention is that it will be f in both cases, so we have to verify this. So let's do the work. So let's begin with what is the meaning of f plus g. It means that f plus g, what is the meaning of f plus theta? The meaning of f plus theta is that f plus theta evaluated at x equals to f of x plus theta of x, which turns out to be f of x plus 0, because theta of x is 0 on the whole interval. But this 0 is the real numbers 0. This is the identity of the 0 real numbers under addition. So f of x plus 0 will be just f of x. This real number plus 0 is just that real number f of x. So confirm, the function f plus theta evaluated at x is the same as the function f evaluated at x. Similar treatment will reveal that our second equality is true. That one we will leave as an exercise. Last item. Let's verify that for each continuous function on the interval a b inclusive, there is some other function that cancels it. Meaning, if f is a real function, is a continuous function, let me correct myself here. If f is a continuous function on the interval a to b inclusive, there exists another continuous function on the interval a to b such that when we add them together, the result is the zero function. So let f be a continuous function on the interval a to b inclusive. Now, the function I want, I'm going to call it minus f, and I'm going to define it as follows. Define negative f by negative f of x equals to the negative of the real number f of x. I have to emphasize something here. I'm thinking of this as a single entity. This negative f is some function like h. What I'm defining is that this function evaluated at x is simply the negative real number f of x. So let's do our verification. Let's verify that f plus negative of f evaluated at x is the zero function, and that the negative of f plus f evaluated at x is also the zero function. Now this time I'm going to verify the second one, leave the first one as an exercise. So what is the meaning of negative f plus f? What is the meaning of negative f plus f? It means that negative f, so what is the meaning of negative f plus f? It means that negative f plus f evaluated at x equals the negative of the number fx plus the number fx, f of x. Now, f of x is a real number. The negative of that is also a real number. What is, they are opposites of each other. What's the result of adding a number in its opposite? 0. So this is equal to 0, which happens to be our function theta. So we have confirmed our property. Okay, with this we conclude our quest to verify the abelian group properties of the set of continuous functions on the interval AB under addition.